This is Unit 0, Review of Chemistry 1, video number 3. We are going to go over chemical nomenclature and formulas. So the first thing that we need to talk about is how to tell the difference between covalent compounds and ionic compounds, because they have different ways of writing formulas and naming compounds. So if you recall back to Chem 1, covalent compounds share electrons. Ionic compounds transfer electrons. So when they transfer, the thing that is losing electrons becomes more positive. The atom that is gaining electrons becomes more negative, and it's the positive-negative that holds the compound together. Over here, they share the electrons in covalent, and that's what holds them together. Covalent compounds and ionic compounds also differ in the type of atoms that combine. If you recall, covalent compounds are usually made up of nonmetals. On the periodic table, these are things that are on the right-hand side. So things like phosphorus, sulfur, carbon, oxygen, fluorine. They tend to bond to each other to form very complex compounds, but they are covalent. We are going to focus on binary covalent compounds for naming just two elements. Ionic compounds are usually metal to nonmetal or metalloid. We also have polyatomic ions in there, so we can have polyatomics. Excuse me. You have a list of polyatomic ions in your salmon color packet from your classroom packet that I gave you. Now, how we name and write formulas is different with covalent and ionic. Covalent compounds, we use prefixes. Ionic, we use charges. So we're going to tackle covalent first because I think they're a little bit easier. So if you recall the prefixes for covalent compounds, one was mono, then we had di, tri, tetra, penta. So that's 1 through 5. Hexa, hepta, octa, nona, and deca. So those are the most common prefixes. There's more, but we don't have to worry about them. So I have two example problems here, CBr4 and P2Cl5. So we always name the first element in these covalent compounds, and we know that they're covalent because we have two nonmetals. C and Br are both nonmetals, so they would follow covalent nomenclature rules. We name the first element using its full name, and if there's more than one, we have to put a prefix in front of it. If there's only one, like in this one, we do not put mono in front of it. So C is carbon. There's only one of them, so we just say carbon. The second part of the name, the element, bromine, we drop the ending and add "ide" to the ending. So bromine becomes bromide, and there's 4 of them, so we have to put tetra in front of it. So tetra bromide. This one, P2Cl5, we have 2 P's. P is phosphorus. There's 2 of them, so we have to put di, so it becomes diphosphorus. Notice that we do not change the ending. And the second part, we have 5 chlorines. Well, chlorine in the second element is the ide ending, so we have chloride, and we have to put the prefix for 5, which is penta. So diphosphorus pentachloride. This one, we're given a name and we want to write the formula. Dinitrogen pentoxide. So the prefixes tell you what the subscript is going to be. So di means 2, so that means we have 2 nitrogens, so N2. Pentoxide, notice that the A was dropped. That's very typical that they drop it if there's 2 vowels in a row. So pentoxide, pent means 5, oxygen's O, so N2O5. So that's really all there is to covalent. So if you have 2 nonmetals together, then you follow this set of rules. If you have more than 2 elements in the compound, or you have a metal, you know you're going to have ionic. So with this one, I have flow charts in your salmon color packet, and those flow charts are going to be useful. So we're going to look at this one here, binary ionic compound nomenclature flowchart. So the first thing we have to do is, does the cation have more than one available charge? Cation is going to be the metal ion, or the first element in the compound is the cation. It's always written cation, anion for ionic compounds. So with that, if we look at our example, you see Li3N. Well, does that cation, does Li have more than one available charge? Well, we have to go to a periodic table. In your salmon color, mine's yellow, but yours is salmon, we have to look up that cation on the periodic table. And for this one, lithium, if you look right in this upper right-hand corner, you can see a very small +1. That's the common oxidation state or charge for lithium. Lithium only has one possibility. It can only be +1.
Okay, this is the last call. Any vocational students headed to the afternoon VOTEC, please head out to the bus now. Thank you.
Sorry about that interruption. So lithium only has one possible charge. Things like manganese have multiple charges. Iron, cobalt, nickel, they have multiple charges. So we're going to have a different way of naming things that have multiple possibilities. But for lithium, all we do is follow that flow chart. So if it only has one charge, we follow the no here. And it says name the cation using its full element name, and then name the anion, the second element, by dropping the ending in IDE. No prefixes. So with that, Li3N, we name the cation, lithium, and then the anion, the N, nitrogen becomes nitride, no prefixes. Lithium nitride is its name. Now, Mn, like we said before, can be +2, +3, +4, +7. We have to figure out what charge it has. So if you're unsure how to figure that out, we can use the anion's charge, which oxygen is only -2, to figure out what Mn is. Each oxygen is -2. There are 7 of them. So all of the oxygens together are -14. Since a compound is neutral, that means all the Mn's together have to be +14. Since there's 2 Mn's, all the positive charge divided by how many gives us that Mn is +7. So now that we know that Mn is +7, we have a way of naming it, and that's called the stock method. So the stock method can be used for anything. So if we follow this, we determined that manganese was +7. We're going to name it using the stock method. So we name the cation using its full name, so manganese. Write the charge of the cation as a Roman numeral in parentheses. Well, here are the Roman numerals, 1 through 8. We want 7, so it's VII. And then we name the anion by dropping the ending and adding IDE. We'll tackle traditional method here in a second because manganese does not have a traditional name. So this one will be called manganese 7 oxide. Our last example of naming something is Ni3PO42. Well, PO4 is a polyatomic, and it is phosphate, and it has a -3 charge. Nickel on our periodic table can be +2 or +3, so we have to figure out what charge it has. So if phosphate is -3 and there's 2 of them, that's -6 total. So all the nickels together have to be +6, and there's 3 of them. So each one is +2. So naming it with the stock method would be nickel 2 phosphate. Polyatomics do not change their endings. But we also have a traditional name for nickel. And the reason I know that, on the back of the periodic table, there's something called a charge card. It has some odd polyatomics, but it also has these bases for traditional naming. These elements all have 2 possible charges. And they all had traditional names. These are ancient elements that have been known for a long time. So there's a different way that we can name them. And on the flow chart, it says, look up the charge, use the charge card to look up the base name. So we did that. Nickel is nickel. Is a charge the higher or lower of the two charges? Well, we said that nickel can be +2 or +3. In our example, it's +2, so that's the lower charge. So we add us to the base name, so it becomes nickelus. If nickel was +3, we would add ick to it, but since it's the lower of the two charges, we add us. And then the ending is phosphate, if it's a polyatomic. So, in addition to nickel 2-phosphate, it can also be called nickelus phosphate. Then finally, if we want to reverse this, if you remember back to Chem 1, you cross the charges. So ferric, F-E-R-R, is one of those base names. So it tells you what element it is. So if you need to look that up, it's iron. The ick tells us it's the higher of the possibilities for iron. So in this case, Fe is +3, because iron can be +2 or +3. Bromate, ATE, that should ring a bell that, hey, that's a polyatomic. So we find it on one of our charts. Bromate is BrO3, and it has a -1 charge. So we never write 1 as a subscript. So when we cross these charges, that 1 becomes a subscript on iron, but it's understood to be there if we leave it blank. And we need 3 bromates. So when this charge comes down, with parentheses around there, so we know that we have 3 bromate ions. So FeBrO3. The last thing are acids. And we're going to go over acids more in depth, but these are the more common ones that we're going to see. And these we just have to know for right now. Hydrochloric is HCl. Sulfuric is H2SO4. Nitric is HNO3. Acetic can be written in a couple different ways. HC2H3O2, or you might see it as CH3COOH, and phosphoric is H3PO4. So you should try to work on the example problems or the problems that are on the next page in your packet.